All right, let's look at the homework 4.5, problem number 3. All right, let's sketch the graph of this given rational function here. All right. All right, so first thing is I'm going to look at the original function and try to extract as much information as possible. All right, so let's look at the domain. All right, so domain, since it's a rational function, we have to worry about the denominator being 0. So we know that x squared minus 9, we don't want that to be 0. And we can easily factor this out. It's x plus 3 times quantity x minus 3 cannot be 0, right? So which means that we know that x cannot be positive 3 or negative 3. Right, so all real numbers except for positive 3 and negative 3. Right, so we got that. And x-intercept, so we put the y equals 0. If you put y equals 0, x has to be 0, so that's going to be 0. And a y-intercept, we put x equals 0, y is going to be 0. So this tells you that it's going to go through the origin. Maybe I should start putting stuff in. All right, so it's going to go through the origin, so I'm going to just place a dot there, right? And then we have to eliminate positive 3 and negative 3. So I'm going to put, let's see, so here's a negative 3. All right, so this would be excluded. So I'm going to just put dotted line so that we don't have a graph there. And the positive 3 is probably around here. So you have 3. And then we put vertical dotted line to indicate that we can't have a function there. All right, then vertical asymptote. You can see that the vertical asymptote is, x equals positive 3 and negative 3. So this guy is actually the vertical asymptote there, and this is going to be the vertical asymptote there. All right, and the horizontal asymptote. All right, so let's do the trick. And since you have a rational function, and you can see that the denominator has a higher degree, which means that this guy is going to dominate. So as x gets larger and larger and larger, the denominator is going to overpower the numerator, so it's going to go to 0. So y equals 0 is the horizontal asymptote. So maybe I should do that. Let's see. I'm gonna put maybe a different. I'm gonna put a green. So right here, horizontal asymptote is actually the x-axis. So here. So maybe I'll just put the horizontal asymptote. All right. I think that's enough from the original function, and we can go back if we need more information. All right, so let's take the derivative. So y prime is equal to, all right, so we're going to have to use the quotient rule, square the denominator, so quantity x squared minus 9 squared. And the derivative of the top is 1 times the bottom is x squared minus 9 minus top is x, derivative of the bottom is 2x. All right, so you can see that this is gonna simplify to. All right, so the denominator looks nice. So you have x squared minus 9 squared. All right, so you have minus 2x squared, and then there's a positive x squared, the negative x squared. So I'm going to put the negative sign outside. Then you have an x squared. All right, that will take care of. So we took care of the denominator. We took care of this guy, and we took care of that guy. So you have a negative 9. So negative sign is already pulled out, so it's going to be a positive 9. All right. So you can see that because of the negative sign, but this part, x squared plus 9, and this part is going to be always non-negative. So you will never get a positive value because this part is positive. and then this part is turns into negative. So we know that this quantity is always negative, right? Which tells you that the graph is always decreasing. All right, so I'm gonna try to indicate that. So it's decreasing, so it's decreasing there, and decreasing there, and decreasing there, and decreasing there. All right, so we got that. All right, then so that's enough from first derivative, and the second derivative. We're going to take the derivative again. So you have a y double prime is equal to, right, negative sign, I'm going to leave this guy alone. And then another application of quotient rule. All right, and square the denominator. So you have x squared minus 9 to the fourth power, right? Derivative of the top is 2x. Times the bottom is x squared minus 9 quantity squared. Minus, you have a quantity x squared plus 9, that's the top guy. Multiply by the derivative of the denominator is put 2 in front. Keep x squared minus 9 as it is. Subtract 1 and multiply by the derivative inside, which is 2x. Alright, so we have that. Alright, so let's pull out the, let's clean up a little bit. Alright, so denominator looks okay, so I'm going to just copy that. So x squared minus 9 quantity to the fourth power. Right, and then you have, let's see, so you have 2x in common, so 2x and 2x. Maybe I'll put that, 2x. Right? What else is in common? We have x squared minus 9 here. There are actually two of them, so I'll take one of them. Right? So you have x squared minus 9. We got that. And I think that's all. So you're gonna collect leftover terms. So you have x squared minus 9. So you have x squared minus 9 from there. And then we have minus 2 times x squared. So minus 2x squared. And then you have 2 times 9. So that's going to be minus, let's see, 18. All right, so that takes care of everyone. And let's see, this part right here is going to simplify to negative x squared minus 27. All right, so what I'm going to do is I'm going to use this negative sign to turn it into a positive sign there and a positive sign. You can just distribute negative 1, right? All right, and also we can cancel. There's a common factor here, and cancel that and turn it into cubed. All right, so once you clean that up, you're going to get, let's see, 2x times quantity x squared plus 27 and over. All right, you have x squared minus 9 cubed. All right. All right, then we're going to have to do a little bit of checking a sign analysis. So you have a number line, and let's see, if I set that this guy equal to 0, this guy is never 0. And this guy is 0 when x equals 0. So x equals 0, second derivative is 0. So I guess I have to put a tick mark there. And also, since it's not defined at the negative 3 and the positive 3, so I have to put that there. All right. Then let's look at the sign of y double prime. All right. So let's try some sample number. Anything less than negative 3, so I'll try x equals negative 4 just to check it. All right, so if you put negative 4, so here, this part is always positive, so we don't have to worry about that. All right, so this is going to be negative, right? and this is going to be negative 4 squared, so that's going to be positive, right? So you have negative times positive by positive, so that's going to be negative, right? So we got that. And between negative 3 and 0, so I'll try negative 1, right? Then you see that, let's see, that's going to be positive, that's going to be still negative, so that's going to be actually going to be negative. So this is going to be turned into a negative. So we know that the negative divided by negative is positive, right? So let's try x equals positive 1, right? So now this is going to be positive. That's always positive. This is going to be negative. So this is going to be negative there, right? And if you try x equals 4, right? So that's going to be, sorry, it's kind of hard to see. Maybe I should erase that. So, all right, erase this and erase that. All right. So this is going to be positive right here. And 4, it's going to be positive, right? 16 minus 9 is positive, right? So everything is positive. So we have that, right? Then, so we know that concavity, right? So according to this, concavity is, it's going to be, here's a negative, so it's going to be a concave down. Maybe I'll do this, right? Concave down. Right here, positive, concave up. Here, concave down, and here, concave up. Right? So now we can sketch the picture. All right, here in this section, before negative 3, we have to draw a picture decreasing and then concave down. And we have a vertical asymptote and a horizontal asymptote. So we know that the graph should look like this. All right. All right, here. Between here, it has to be decreasing then concave up. You're going to have to hit that point, and you have a vertical asymptote. So we know that this is going to look like this. Right? After that, decreasing then concave down and vertical asymptote. So you have a picture going to look like that. After that, it's decreasing then concave up and the vertical and the horizontal asymptote. So you know that the graph is going to look like that. Right? Let's see if we have something similar, right? So you can see that the second one, right? Let's check the answer. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.